Okay, I'm here now. We can get started. So thank you all for being here. And well, what can you expect in this talk? So I will talk about Debezium and change data capture, of course. To motivate it a bit, I will tell a bit about what is the issue with dual writes and how can we use CDC to overcome this. I will talk a bit about some CDC patterns and use cases, things like those. And finally, I will touch on a few practical matters. How can we run this in Kubernetes and so on. And definitely, I will try and keep an eye on the chat. So if you have any questions during the session, definitely ask them and I will try to get to them. And I also understood there will be time after this slot, so this room won't shut down right away. So we also can stay a while longer and take more questions there. All right, so let's get into it. To give you a bit of context who I am, so I work as a software engineer at Red Hat, and I work on this project, Debezium, which is the project I'm going to talk about today. I've been with Red Hat for a few years, and I've been working on several projects. I've been working on hybrid projects for a long time, and I'm also a little bit involved with the Quarkus effort, which you surely have heard about. I do a few other things, and if you are interested in what I'm up to, I suggest you follow me on Twitter, and I will share all the news and what's happening. All right, so let's dive into it. And I would like to start with a common problem, I would say. Many of you have encountered in your real-world projects, and this is something like this situation. So you have this kind of, maybe it's a microservice or some sort of traditional application. Let's say it's an e-commerce application, and well, of course you have a database, and probably you have something like a REST API, and overall the flow looks like this. The user comes, they send a request to your service, and then some data gets processed in the database. That's all fine and good. Now, what oftentimes happens, maybe this thing goes real well, but you figure at some point, maybe the performance of this application isn't so great. Maybe there are some views in this application which are a bit slow, which take long to load. And well, what do you typically do? You add a cache. So what your service now has to do, it has to go to its database, persist the data there, and then also, of course, it needs to update the cache because, well, next time we go to the cache, we would like to get the current data from the cache. We don't want to have stale data. So we need to update those two resources, our database and our cache. And then things again are fine. And maybe your PM, your product manager comes around and they say, okay, I would like to have a new feature in this thing. I would like to have something like a search on our data. So maybe in this e-commerce application, we would like to have search on our product data or our persistent purchase orders and so on. So, well, databases by themselves, they are usually not so great for implementing full text search. So what you typically do is you add something like Elasticsearch or Solr or something like that as a separate dedicated search index. And now the picture looks like this. Whenever a new request comes in, the customer, they place a new order, it needs to update those three resources, the search index, the database, and the cache. And on the surface, this looks good, this looks fine, but there's a problem with that, and actually multiple problems. And the first problem is there's a concern of availability here. So let's say our search index is not available for some reason. Maybe there's a network split, maybe it's just broken down, I don't know what's happening, but now you're in a bad position because, well, maybe you already updated the data in the database, but then you cannot send this request to Elasticsearch, so you end up in an inconsistency. Or maybe you just don't do the database right, but then what do? You need to somehow keep those requests around, buffer them for later on. So this availability is a problem, right? Because we are tied to the availability of all those three resources. So that's the one problem. The other problem is there's also an ordering concern. And this is, well, those three things. The search index, the cache, the database, they are not updated as part of one global, one shared transaction. And this means you don't have any kind of ordering guarantee. So what could happen is you have two data changes and you apply them in different orders. So to give you an example, let's say you have this purchase order already existing. Now you do two updates. Let's call them A and B. And what could happen is you persist A before B in the database. And then by the ways of how the requests are routed, it could happen that B gets persisted before A in the search index. And this puts you really into a very bad position because you end up with inconsistent data. So all your writes did succeed, but the order wasn't right. So you have a different state in the search index than what you have in the database. And your search index would return invalid, inconsistent results. So again, that's very bad. And that's the, I would say if you were to leave right now, this would be the most important point. Don't do this. So we call this dual writes. And I always say, friends don't let friends do dual writes. So never, ever do this because it's guaranteed you end up with inconsistencies across those different representations of your data. Of course, the question now is, what can we do instead? So we cannot do this in a safe way. We cannot update multiple resources, but well, we always can update a single resource. And I would say our database, well, if we cannot write to our database, then we are in deep trouble anyways, right? So I would say this is kind of a given. We can take this as a guaranteed thing that we can write to our database. And what we can do now is we can actually use this database as the source for our changes and drive the update of those other resources based on that. And this is where change data capture and Debezium comes in, because it's exactly doing that. So it taps into the transaction log of the database, it gets the changes from there, and then we can, send those change events into something like Apache Kafka, and we can set up consumers to subscribe to those topics and propagate data to sync systems. And now this addresses, or this really removes those concerns which we had before. So we don't have the availability concern. So now, well, I need my database, okay, but otherwise, let's say my Elasticsearch index isn't available. I don't care, because all this pipeline, this runs asynchronously. So whenever one of those downstream resources isn't available right now, for me as the order service, this doesn't matter, because this will happen asynchronously. So we will catch up later on. So we don't have the availability concern, and we also don't have the ordering concern, because CDC, change data capture, it gets the data from the transaction logs in the database. And this is really the canonical source of how the transactions have been serialized. And if it gets hold of that, we will have a guaranteed order, and it will be guaranteed that the changes are applied into the exact same order. First of all, they are sent to Kafka, and then also consumers will consume them in this same order. So we also don't have this ordering concern. And what we can do now is we can set up consumers for the data in Kafka, and they will subscribe to these topics. They would then take the data from those topics and write it to the search index, write it to the cache, or what any other kind of sync system you have. And this is another beauty of this kind of model. You can add more consumers down the road. You can enable more use cases. So let's say you would like to add a data warehouse to that. Well, you would just essentially add another consumer for the data in Kafka. And what you can do is now, provided everything has been configured correctly, you can reread a topic from the very beginning. So you get the entire change history of your data and send it to this data warehouse. And now you have enabled another use case. And maybe when you set up this pipeline originally, you didn't even know, or you didn't even think about that use case. So that's another very nice advantage of this kind of architecture. So that's in a nutshell why you should not do dual writes, and how CDC and Debezium can be a way out of that. And I hope this makes sense. I hope this motivates the thing a bit. So now let's talk a little bit about how Debezium does fit into all this. So in a nutshell, it's an open source change data capture platform. So it implements, or it enables you to do this kind of architecture. And now the thing is, there's just no single API which would be offered by all the databases out there which would allow you to get change events out of this. So there's one API in MySQL, there's called bin logs, and you get changes from the bin log. In Postgres, you have to write a head log. So again, it's a different format and different ways how you get the data out of it. And each and every database has a different way to expose this data from the transaction log. And this is where Debezium comes in. It essentially, so we do all this research effort. So we figure out how do we get changes out of Postgres, out of SQL Server, and so on. Then we produce one rather abstract, one rather generic event representation, and that's what we send to Kafka, and that's what consumers receive. Which means if you have a consumer, for you, it doesn't matter too much, does this change event originate from MySQL or Postgres or any of the other support databases. So it's rather abstracted. So that's essentially what Debezium does. It's a set of CDC connectors for a range of databases. And now I could tell you many more about its features. So there are things like snapshotting, for instance. So very often you don't have your transaction logs from 5 years ago, because it just wouldn't be possible to keep this in an accessible state. So this means if you set up this connector now, you need to start with some sort of consistent initial data sync. And this is what the snapshotting is doing. So it essentially scans all the tables you have configured, and it will get the current state of the database, send this to Kafka. And once the snapshot is done, it will fail over to this log reading mode, getting data from transaction logs. It's all open source. It's Apache licensed. It's on GitHub, the source code, of course. And what I'm very happy about, there's a very active, very lively community around this. So as I mentioned, I work for Red Hat, and there's Red Hat engineers working on this project, but we are not the only ones. So there's many other people working on that. I think by now, I don't have the latest number, but it's more than 150 or 160 different people who have been contributing to Debezium. It's based on Apache Kafka, so that's what I'm going to talk about mostly today. So people use this with Apache Kafka, but then also you can use this in different ways. There's different ways for deploying Debezium. So you can run it as a library in your Java application. You can connect it with managed messaging infrastructure like Amazon Kinesis or Google PubSub and those kinds of things. But most of the times people really use this with Apache Kafka for very good reasons. And it's heavily used in production. So if we have on our website, we have a list of production users. So there's really large deployments of this in production. And as I mentioned, now we have different connectors. So for each database, we need to have dedicated connectors. So there's support for MySQL, Postgres, Mongo, SQL Server. So they are really stable, very mature. And we have a few incubating ones. So this means they are under active development. And well, maybe their format, which they emit, this might still change, those kinds of things. But work is happening there. And there's things like DB2, Cassandra, and Oracle, for instance. And Cassandra, that's a very interesting one, because actually here it's people from the community who lead this work. So we have this company called WePay. They are heavy users of other Debezium connectors, MySQL, and they also they deploy Cassandra in their production environment, and they worked on CTC support for that. And at some point, they decided they would like to open source this under the Debezium umbrella and work on this with the open source community together. So that's Cassandra, and the same thing is happening right now for Vitess, which is a sharded way of operating MySQL, essentially. There's this company called Bolt, which are right now in the process of open sourcing a Vitess connector under the Debezium umbrella. So I'm really excited about it. Now, I should mention, or maybe you think, well, okay, that's all nice and fine, but I could just go to my database and I could just do some sort of polling and ask, like, every minute, is there a new record in this particular table? And this is what I would refer to as a query-based C2C approach. And well, whereas what Debezium is implementing, that's a log-based C2C approach. So it gets the data from the transaction logs. And you might wonder, which one should I use, or what's better? And just to give you an understanding or an impression how those things differ, well, if you think about this query-based approach, there's some sort of conflict between how often you do this and how current this data is, and also what kind of load this generates on the database. So let's say you poll every minute. Well, if you have changes which happen within a minute, let's say something gets inserted and deleted within those 60 seconds, you would not know about it. You would just miss this, right? But then you might say, okay, so I will try and query more often, like every second or so. But, well, no matter how often you do this, there's still a chance you miss changes. But also at some point, just this gets prohibitively expensive, and your DBA would probably come to your cubicle and say, don't run this query all the time. This is really putting our database under too much load. Don't do this. Whereas with the log-based approach, you don't have this. So this really adds a very low overhead. It's very efficient, and so it's you never miss any changes, and it's also very resource efficient. Then, well, if you have this polling-based approach, well, you need to think about how do you actually identify your records which need to be captured, right? So you need to have some sort of like an update column in your tables. Whereas if we get changes from the log, well, we don't need this. So it's really transparent in terms of the model of your tables. Things like deletes. If you add a delete, or sorry, if you delete a record, well, if it's gone from a table, you cannot query for it, right? It's just gone. Whereas in the log-based approach, also a deletion, that's just an event which gets added to this append-only transaction log. So the log-based approach will also capture deletes. So those are all advantages of the log-based approach and of what Debezium is doing. There's one thing, and that's the installation and configuration. So as I mentioned, well, if there's no Debezium connector for your particular database, well, you're out of luck. So then you cannot really do it. But otherwise, if there's a connector and you can configure the database the right way, definitely I would always recommend and go for the log-based approach. I was mentioning, I was telling, well, if we get those change events out of the database, but I didn't really tell how they look like. And this is what I'm explaining here. So if you have used Kafka before, you will know that records in Kafka, they always have a key and a value. And the key in our case, that's the primary key, or that represents the primary key of the table we are capturing. So you have maybe a primary key just with a single column. Then you would have a message key which has a field which resembles that. If you had like a composite key containing multiple columns, then you would have also a complex message or structure for the message key. And this key, by the way, determines the routing of those change events within the topic. So all events with the same key, they will go into the same partition of this topic, and then the ordering is guaranteed for all the events which pertain to the same primary key. So that's the key. And the value, this really is this structure which we see here on the right-hand side. So essentially, this really describes this change event. So you have the old state of a row before, the new state of a row after, and then you have some sort of metadata. So now for an insert, well, and that's what we see here, there wouldn't be a before state because there's just no previous row state. So we just have the after. For update, we have both before and after, and for delete, we just would have the before state. And in the source block, we have things like the database name, the table name, like a timestamp, position and log file, maybe the query which was causing this change, and some more metadata. So that's very useful for consumers oftentimes. That's the semantic structure. How does this look like? And then in Kafka, well, every record in Kafka is just a binary blob. So we need to think about how can we convert this semantic structure we see here on the right-hand side into the binary representation, which is sent to Kafka. And this is where the converters come into the picture. So they're essentially the tool for serializing this data into byte arrays. And there's support for different converters out of box, things like JSON or Avro, and just very briefly touching on that. So definitely what I would recommend is to use a schema registry. And the schema registry essentially is a external service which takes or which keeps record of the schema of your events and how they evolve. So let's say you have this customers table. Well, there you see in the before and after, the fields there, they resemble the table structure, right? So we have something like the first name, the last name, email, and so on. And now if I were to add another column to this table, I would also have a new schema for those messages. And adding the schema into each and every message, this would be very verbose and would represent a big overhead because we don't change our schema like every day. Our table schemas tend to be very stable. And this is why such a schema registry makes so much sense, because then you have the metadata of the schema in one place, and in the actual change events, you only have like a small ID, which is the reference to the schema in the registry. And the consumer can go to the registry and resolve the schema from there. So this is a very useful thing to do. All right, so that's really Debezium CDC. I would say in a nutshell, there could be many things more said about it, but I think you have an idea what it is about. So let's talk a bit how we can put this into use and how we can employ this and what we can do and why we would like to do this. Now, Sebi is asking, can we use this with cloud events? And yes, actually we can. So if I go back here, so here, this is our Debezium specific event representation. There also is support for cloud events, which essentially is a defined standard for event structures with defined fields like, I don't know, timestamp and a type name and those kinds of things. It's like an envelope, and the actual payload of the event sits within this cloud event structure. And Debezium can optionally produce its change events as a cloud events structure. And then what we essentially see here, this would be like the data payload of such a cloud event. So that's supported. My pleasure. All right, so now the way I like to think about that is really CDC is like it's liberation for your data. So you have this database there and your data is in there, and really instead of having to go there and query for changes, you know, it comes essentially to use. Whenever something changes, you get notified and you get invoked and you can react to the data change. And you can do so many things with that. So you can just replicate data. You can update your search index or your cache, as we've seen in the original example. You can do things like streaming queries. This is super interesting, using things like Kafka Streams or Apache Flink, where you continuously would like to run queries as your data changes. So let's say you're interested in your order revenue per category in a sliding time window kind of fashion. So what is the revenue of my furniture category in the last 60 minutes. And whenever a new purchase order comes in, this should be updated. Maybe it should be pushed to some sort of dashboard. So that's streaming queries. That's super interesting. You can use it to synchronize data between microservices. I will touch on that later on. You can do things like audit logs and many things more. So really, it's like liberating your data and giving you all the changes at your hands, and you can react to it and just implement many, many exciting use cases with that. And let's dive into a few of those. The first one is data replication. And what's very interesting about that is it's essentially a matter of configuration. So you don't have to code, you just have to configure things in order to set up such a data streaming pipeline. So this is how it could work. So we have our databases. Let's say I have MySQL and Postgres, and I have Apache Kafka. And then there's another component which I really didn't mention so far, and this is Kafka Connect. And Kafka Connect is another project from the Apache Kafka umbrella. And essentially, it's a runtime and a framework for connectors. So you have source connectors, which take data from some kind of external system and take it into Apache Kafka. That's source connectors. And then you have sink connectors, which take data out of Kafka and send it to some sort of third-party system. And now, as you will have guessed, essentially Debezium here is used as a set of Kafka Connect source connectors. So you deploy those into Kafka Connect. It's its own service, its own cluster with failover and everything. And now the Debezium connectors, they get deployed into Connect. They subscribe, or let's say they connect to the database, like MySQL or Postgres, and then they send the change events into Kafka topics. And by default, there's a mapping, like a one-to-one mapping between a table, which we capture, and the corresponding Kafka topic. So you would have a topic for your customers table, for your purchase orders table, and so on. Then you could set up sink connectors, and they would take data from those topics and send it to Elasticsearch, your data warehouse like Snowflake, or maybe Google BigQuery and so on, or like your cache, like InfiniSpan. And really, setting up those connectors, as I mentioned, you just configure this, and it's a it's a matter of YAML configuration or whatever you prefer, maybe JSON configuration if you use the REST API for that. But really, you don't have to code, so this makes it very accessible for many. It widens the amount of people who can work with that. And the very interesting family of connectors is those of the Apache Camel connectors. I believe my good friend Klaus Ibsen from the Camel project, he was also speaking here at Java Day Istanbul. And one cool thing which they recently did is all the Camel connectors, they have like hundreds of connectors for all kinds of things like Salesforce and Hadoop and whatnot. They can also now be used within Kafka Connect. And this really widens the number of things you can do here by a large degree, because essentially for everything there's a Camel connector, and now you can use this via Kafka Connect, and this can be used with Debezium on the source side, and you have this nice end-to-end flow using Debezium and Camel. So that's really very exciting. And I should mention, this happens with a very low latency. So this is taken from a blog post by a company called Convoy, and I think they are like something like the Uber in the freight forwarding space. And well, they had an ETL, a traditional ETL pipeline, and here you see their delay between the data change in the operational database, and when did the data change arrive in the data warehouse. And you see this, was pretty volatile between 1 hour, 2 hours, maybe even more than 2 hours. And then, well, you see, at some point they switched over to the CDC-based approach and using Debezium, and you can pretty clearly see in the chart when they did the move, and this is when they had this very low latency. And well, what I can tell you from our users, and it depends a bit on the connectors, but you look at an end-to-end latency of low seconds, or sometimes even a sub-second, like milliseconds. So I know of people who have like an end-to-end delay between production database and Google BigQuery of about 2 seconds. So that's pretty impressive. So that's replication in the widest sense. Also search index and so on, that's all, I would count that under replication. So let's talk about auditing, because that's also a very interesting use case, which I see more and more. And now if you squint a little bit, such a Kafka topic with your change events, with all your inserts and updates and deletes, that's kind of like an audit log. So you have the history of your data. But now typically you would like to have some more metadata, like what is the user who did this change? Maybe some sort of client configuration, like the client IP or the device configuration, maybe use case identifier, all those kinds of things. And now Debezium can really capture this additional metadata from the actual tables, because you won't typically store this there. So what can you do? Well, what you can do is you can have another table which your application maintains, and where you essentially have one record per transaction. And each record represents the metadata for this transaction. So there you would persist things like the username, use case identifier, and so on. And this would be keyed by the transaction ID. So the primary key, that's the transaction ID. So this would be another table. You would also set up Debezium to capture that. So you would have another topic with the transaction metadata. And then you could use stream processing with Kafka streams and correlate those events and write them back to an enriched topic, which contains the actual change event data with this transactional scoped metadata. And I have a link here on our blog where we describe this in depth, how you do it. Surprisingly, it's a bit heavily convoluted to implement, but just to dive a little bit into the details. So how it would work is, so you on the right-hand side here, I have my customer, and I mentioned already this source metadata, which exists in each of my change events. And there's the transaction ID, that's part of that. And now in our transactions topic, so that's what our application needs to maintain, we would have this transaction scope metadata, and this would be keyed by the transaction ID. So we already see we have the transaction ID on both sides. So it is part of our actual change events, and it's the message key in our transactions topic. So we can correlate it. And then we could, for instance, do something like that, take the transaction scope metadata and put it back into the source metadata block and write this to this enriched customers topic. And now, as I mentioned, that's quite complicated to implement, actually, because what you need to be aware of, there's no ordering guarantees across topics. So what could happen is you receive this change event for your customer, but at this point in time, you have not received yet the corresponding transaction metadata event. So you need essentially to buffer your change events until all this metadata becomes available, and only then you can process all those change events and do the enrichment. So that's the trick. You need to buffer this. Kafka Streams has concepts like a state store for that. So that's something you could do, but it requires a little bit of coding. So that's auditing. So let's talk a bit about microservices. And now, if you think about microservices, really the idea there is you would like to have dedicated services for dedicated parts of your application domain, right? So let's say you have this e-commerce scenario, you might have services like order, item, stock. But now the thing is, well, they have each their own database. You don't want to share databases in the microservice architecture, right? So each service has its own database. It could be one uses Postgres, another one uses a MySQL, like a NoSQL store, Mongo, or whatever. But really, those services, they don't exist in isolation, right? They need to be aware of what's going on in the other services, or they need to be aware of the other services' data. So let's say this order service, it receives a new purchase order request. It needs to have information. Do we still have this item in the warehouse? So what's the stock count? Or maybe from the item service, it needs this information. What's the weight of this and what's the price, so we can do our pricing and so on. So the order service, it needs to have information from these other systems. Now we could, well, just go and do like a synchronous REST request, but then again, we have this problem with the coupling, right? So we really cannot, or we shouldn't do this, but we can actually achieve what we need by turning things around, and essentially by having those systems publish data streams with their data changes. So the item system or the stock system, they could expose a CDC data stream, and then the order system could subscribe to that. It could persist the data, the item data or the stock data, in its own local database. And it would do this in an optimized way, so maybe just a subset of the data, maybe denormalized, so it's very efficient to access. But then really the order system, it wouldn't have to synchronously reach out to those other systems. So CDC could help us in such a microservices architecture. Baki asks, should I think disaster recovery based on Kafka Connect with Debezium? Or, yeah, I will touch a bit on that later on. Okay, hang on for a second on those kind of things. And now there's one concern with this kind of architecture, and this is, well, it kind of exposes the internal structure of your tables. So let's say in the stock system, you have a stock table, and you would expose your structure of your tables to the OR system, and you might not want to do this. And this is where this Outbox pattern comes into the picture. So this allows us essentially to more consciously design what kind of changes or events we propagate or publish to other systems. So just remember what our system cannot do. It cannot go to its database and send something to Kafka at the same time, because friends don't let friends do a write. So that's something we cannot do. But what we can do is we can update multiple tables in our database within one transaction, right? And the idea here is our order service or our item service, whatever, they would update their own internal business tables, and then at the same time, they would also do an insert into what's called the Outbox table. And the Outbox table, this really is essentially like an event queue which contains events which are meant to be sent to other consumers. You would then set up Debezium, and you would only point it to this Outbox table, and it would take the changes from there, and maybe basically you would have some sort of event type in this table. You would have Debezium send this to different topics, like order events or creditworthiness check events in this example. And then different services could subscribe to those. So there's many things more to be said about this. Just briefly here, you would have things like an aggregate type, so you can differentiate different types of events. And then the payload, really, that's up to you what you put into this payload structure. And this is the beauty of this model. So here now you have abstracted from your internal table state. Really, you expose consciously designed contract to your consumers, and this could be JSON or anything else. Again, we have a blog post on our blog which describes this in depth. There's a complete comprehensive example, and there's dedicated support in Debezium for implementing this pattern. So if you are into microservices, definitely check this out. All right, the Strangler pattern. I need to take a look a bit on your clock. I think I will have to skip something. But let's talk about the Strangler pattern. So here, the problem very often is you don't start on the green field. You have already existing services or like an existing monolith. And now maybe you would like to move to a world of microservices. And the question is how you can do this. And it turns out Debezium can help you there. And the idea, well, is something like this. So maybe you have this monolithic application, which has different touches on different matters of your domain, like customer and purchase order and so on, and there's a single database. And now you would like to have a new functionality. So let's say a new view, like the orders view of a given customer, and that's something you decide you don't want to implement in the existing monolith. You would like to implement it in a new microservice. So what you can do is you start on the side with such a new service. So that's where you implement your order list. And now the first trick is you put some sort of routing component in front of that. So like Envoy proxy or an API gateway or HA proxy, whatever, really like any HTTP proxy. And now depending on what kind of URL gets invoked, either the request gets routed to the old monolith or to this new microservice. And now in this first example, only our new customer orders view, this would be satisfied and routed to the new service, and everything else would still be served from the old monolith. But of course, now our new service, it needs to have the information from the monolith, because all the writes for this functionality or for the customer data, they still go to the old monolith. So we can use CDC to propagate changes from this old monolithic database over to the database of the new service. And of course, you might apply some sort of transformation. So maybe you do some sort of cleanup of your data and renaming things and adjusting types. So just, to have some sort of anti-corruption layer in there, so you don't expose the structure of your old legacy model to this new service. Now, what you also can do is you can keep going, and maybe at some point you also route the writes for the custom functionality over to this new service. So at some point you have everything which relates to writes, which relates to customers in this new service. But still, there might be a dependency with other components of the old monolith. Maybe you have this order component, and this also needs to be aware of customer data in some way. So you could also set up CDC again for this new database and just synchronize the customer data back to the old monolith. And so you just need to be careful that for each kind of data, like a table, or maybe in terms of domain-driven design, like one bounded context, you just have the writes going to one side. So there should be one dedicated owner for each part of your domain, because you would not want to redirect your data, in an endless kind of loop between those two databases. So writes for one particular part of the domain should only be done on one side of those of this architecture. So that's the Strangler pattern. And now I wanted to touch a little bit on a few practical matters. And the first one is actually deployment topologies. And I'm just briefly touching on this. So the idea there is, and this actually it kind of addresses already this question by Baki about failovers and disaster recovery. So, well, people, they don't run a single database of a single instance of their database. Typically, you have something like that. You have a cluster of databases. There's a failover mechanism. Now, what happens is, if the one primary node, it fails, this new node becomes the primary, so like an earlier standby node. And now, of course, we need to get changes from that new node. So essentially, in the simplest way, you would have to reconfigure Debezium to get the changes from this new node. And obviously, that's not desirable because you want to automate things. So what people very often do is they put something like HA proxy in between, and then this takes care of this failover aspect. So really, Debezium itself, it would just get to HA proxy. This would be like a constant address and everything, and the failover that's encapsulated between HA proxy. And now also the Debezlum connectors, they actually do reconnect. So let's say we have a connection loss in the probably would have in the caused by this failover, then we would Debezlum will automatically reconnect and would continue to read the log. So that's automatic failover. Another thing is sometimes people are concerned about configuring their database in the way it needs to be configured for CDC. So for instance, for MySQL, there's the transaction log is called the bin log, and the bin log, it needs to have a specific format so we can get the changes out of it. So, and sometimes people are reluctant to change the bin log format of their primary database. So what you can do is you can again set up some sort of cluster, and you have a secondary node in between. And now you just set up the right bin log mode in that intermediary node. And well, you would use the MySQL replication mechanism to get data from the primary to the secondary node, and then you would get the changes out of that via Debezium into Kafka. And CDC would not touch a primary node. Of course, you pray for that by means of increased latency because you have an additional hop in there. But some people do that, they find it worthwhile. And yeah, that's about high availability for connectors. So sometimes people are, and maybe that actually addresses the question of bug here a bit more, people are concerned about the stability of connectors, or what's the story about failovers in Kafka Connect itself. And well, Kafka Connect is a cluster, so there's HA built into that, and connectors could be restarted on a different node. But here in this case, that's actually reported by a user. So they had the concern, they don't even want to bear the downtime of a connector failover on the Connect cluster. They want to pay that delay essentially. So what they do is they run multiple Debezlum connectors for the same database. And well, if one of them dies, it doesn't matter because they still get the data from the other connector instance into Kafka. So that's fine. But of course, they have, if all goes well, like 99% of the time, they will have each change twice because they have set up the same connector for the same database. So that's why they need to have some sort of deduplication component in there, which essentially detects, okay, I've already seen this change event, so I can ignore the second one. So, but some people do that if they have like this really tight requirement in terms of just not being able to accept any kind of downtime. Well, nowadays, many people run their stuff on Kubernetes or things like OpenShift. And well, the question, of course, how do you run Kafka? And I'm not sure whether there was a talk on that or not, but really what I would definitely recommend is use an operator for that, a Kubernetes operator. And what it does essentially for you is instead of you having to use the CLI to define your Kafka topic and your Kafka cluster and everything, you define this in a YAML-based description, like a custom resource. And then this operator, it will take care of making the Kafka cluster adhere to this structure. And now let's say one of the Kafka nodes dies, the operator would detect it and it would spin up, for instance, a new node which takes the same identity on a different node in your Kubernetes cluster. So that's definitely a great thing to do to run things on Kubernetes, and it enables this what we call like GitOps, right? So for instance, in terms of setting up your connectors, there's also a CRD, a custom resource definition type for Kafka Connect connectors, as we see here on the right-hand side. So this is an instance of the Postgres connector. And then there's an operator which would configure the connector for you in the Kafka Connect cluster. You could version the thing and so on. And now this comes with many advantages. It gives you some sort of automated scaling, or things like upgrading gets much easier because, well, essentially the operator can take care of upgrading your Kafka nodes in a rolling fashion. So that's I would say a very recommendable way to run things in Kubernetes. And now, speaking of running things in production and bootstrapping things and configuring and so on, it's the first time ever I'm going to share this in a talk. So you are like witnesses of a world premiere here. So the Debezlum community right now, it's exploring what could how could a UI, a user interface, look like for Debezium? Because, well, as I mentioned, until now, you either use CRDs with the Strimsy operator, or maybe the Kafka Connect REST API, but then really there's some sort of barrier to getting started with that. And this is where we figured, okay, let's try and think about how could a user interface look like, and provide you with some guidance and give you assistance there. And this is what's happening right now. So those are those are actually still mock-ups here, to be honest, but still there's already a proof of concept which implements that. And now this will really simplify this. And for instance, if you think about the selection of the tables, so we have table filters with includes and excludes, and this gets much easier if you do it in such a visual way. So you don't have to, think about regex, regular expressions, and hope for the best that they are applied, because here right away you would get your feedback. So you enter your schema filters, and instantly you would see which tables match this configuration. So you are really sure you configure the things in the right way and you extract changes from the right table. So as I mentioned, you're the first ones to ever see that, and I hope we will move forward with that. Right now, it's a proof of concept. It's happening in this GitHub repo, so everybody is invited to, well, follow along and contribute, of course. And, well, we will soon announce this more widely and, foster feedback from the community and see how people react to that. And I really hope this takes things to the next level and making this more accessible and easier to get started with. And the very last thing I wanted to mention is single message transformations. And this, I just mentioned this because this comes up so often. And very often people have questions like, okay, I get, my timestamp columns, I get them from Debezium in, I don't know, milliseconds since epoch. How can I change this into a string-based adhering, a string adhering to a specific date format? Or how can I route data from multiple tables to the same topic? Or how can I deal with things like evolution of my data, maybe renaming columns and so on? And like in, I don't know, every third time, the answer for those kinds of questions is implement a single message transformation. That's a concept which comes from Kafka Connect. And essentially, it allows us to modify messages either before they are sent into Kafka or then before they are taken out of Kafka. And you can do many, many things with those. We have a few ready-made single message transformations, SMTs, coming with Debezium. So there's something like a routing component, something which ensures compatibility with, let's say, the JDI sync connector, those kinds of things. But you also can build your own. And just to give you an idea of what you can do is, you could have an SMT, and maybe at some point we would have this as part of Debezium, actually, which externalizes large column values. So let's say you have a column in your database which represents some kind of blob, maybe an image. And now I know you're not supposed to do that. You're not supposed to store image data in your database. But, well, let's be honest, things happen, right? People do it. And now, well, maybe you don't want to send this kind of binary data into each and every change event, because, well, Kafka messages, they can only be so large. I mean, you can configure the maximum size, but really shouldn't go to multiple megabytes and so on. It would give you a decrease in throughput and so on. So, and what you could think about is externalizing this data, and you could use an SMT for that. So let's say I have something like that. I have this image data, and, well, instead of putting it into the change events, I could take this blob data and, for instance, store it into an S3 bucket. And then in my actual change events, I would just propagate the coordinates of this file, like name and the bucket name and so on, so making my message much smaller. And then a consumer could come and it could take the data from the S3 bucket. Now, if you think about this, if your image data, let's say this is part of your customers table, and the profile picture, this doesn't really often get changed, but then maybe you have change events for other changes in this table, you would send again and again this unchanged image data as part of your image, as part of your change events. And such an SMT could be a nice way for addressing this solution, and so addressing this problem. And I'm just mentioning this to give some idea what kinds of things you actually can do with those SMTs. So that's a very useful thing provided to you by Kafka Connect. And to wrap it up, I hope I could convey that change data capture really is liberation for your data, right? So as I mentioned, you have the data sitting there in your database, and now it's eager for you to interact with it. So whenever something changes, you can react to it, and you can send it to another data store. You can run your streaming queries. You can update CQRS models. So I didn't even talk about CQRS, like command query responsibilities, segregation, essentially an optimized architecture where we, denormalize our data in order to satisfy different read kinds of requests very efficiently. And of course, they need to be kept in sync with your canonical write data model, and CDC would be one way for implementing such kind of architecture. If you have microservices, I mentioned the Outbox pattern, I mentioned the Strangler pattern. They are definitely great patterns in the context there. And by the way, so we have the blog post about Outbox on the blog. I will hopefully write something soon on the Strangler pattern because I think it's a really cool use case. And well, Debezium really implements all this for you in an open source fashion. It's Apache licensed. There's a growing number of databases. So really this gives you all that what we have seen today. And just to reiterate, friends don't let friends to do the right. So that's really what you never should forget. And just lastly, a few resources. So everything is on debezium.io. There's a very thorough documentation. Those online resources, which I've mentioned here, this is a list of tons of external blog posts. So they are not, conference talks and so on. Most of the things are not written by us, it's by users. So you get a very good impression how people put this into use. We have a blog with all kinds of interesting things like the audit pattern, audit log pattern, and so on. Source code, everything's on GitHub, of course. And finally, if you would like to follow along and be informed about the latest news and updates and so on, then definitely you should follow @Debezium on Twitter. And I cannot believe it. It's like right on time, 45 minutes. So now it's time for all your questions. I hope I could answer the questions which we already had, but I hope you still got many more questions, and I will be very happy to answer them. Thank you, Rustam, but it's not a question. Thank you guys for being here. That was very nice. So let me know what you want to know, and I will be very happy to answer. You're very welcome. So Sebi, any other questions from you? I know you're always very interested in stuff. Thanks, I could. Appreciating it. Oh, the UI, is that running on Kubernetes? So that's a great question. Yeah, as an operator. So not yet. So right now, this is really very early. So as I mentioned, you're like the first people ever I was showing this to. So right now, really, to give some background, there's a Quarkus-based UI backend which drives this. Then we have the React-based components as the actual front end. And right now, it's really it's there on the GitHub repo. You can run this, using Quarkus dev mode or whatever. But there's no container image yet and nothing else. But yes, eventually, this will, of course, there will be a container image. There will. I mean, I need to say we need to decide, do we move forward with that, right? So as I mentioned, right now it's in proof of concept. But I would say if we move forward, then yes, there would be an operator for running this on Kubernetes. There would somehow be integration with Strimzy, so you could spin up maybe a Strimzy-based connect cluster based on the things you have configured there. So yes, we will have all those things. Right now, it's a very early stage of exploration. For right now, we are really, we are focusing on the interaction patterns. So this kind of table selection flow, which we have seen. So that's what we think about right now. How can we optimize this? How can we provide a value for the user, which goes beyond them just, creating this kind of REST-based request? So that's what we are exploring right now. And once we have moved forward with that, we would put it into production, as you say, via container images and Kubernetes and everything. Yeah, definitely. Give it a try. It's all there. You can just run it. You can try the dev mode. It's really awesome. I learned already a lot about the front-end kind of things because I'm no front-end person at all. But then they have like their own complete own build tool chain for React. And I forgot all the names like Yarn and stuff like that. But yeah, it's part of that. You can run it. It's described in the README, so it's really easy to get started with. When will the Oracle connector be ready for GA? So Serkan, thank you so much for this question. This comes up in, I would say, every talk. The problem right now for Oracle is, so there's our current implementation that's based on what's called the X-Stream API. And this is an API which, unfortunately, isn't part of the Oracle license itself. So in order to use this API, you need to have a license for the Golden Gate product, which makes this very pricey. But that's the current state what we have. Right now, what actually is happening, there's somebody from the community, they work on an implementation, on an alternative implementation, which is based on LogMiner. And LogMiner, that's part of the Oracle database itself, and it provides essentially a way to access the transaction about the redo log in Oracle. And well, hopefully we will have this alternative implementation, and this will be much nicer in terms of licensing. And actually, we hope to move, as right now work is happening on this. Folks from the community have spent tons of time working on that, and they already use this internally. And now there's a pull request pending on GitHub, but I hope this will be wrapped up for the next 1.3 preview release. It still would be an incubating state, and we will see when we will move this to GA. So I cannot really tell you that, but I can tell you there will be a new incubating implementation based on LogMiner. You're welcome. Any other questions? Don't be shy. You see, yeah. I hope so too. I mean, I had booked my flight and my hotel and everything for coming to Istanbul. I believe it was in March or April. I was so looking forward to visiting you guys, and then I couldn't make. Well, nobody could make it. So I really hope we can do it next year, and I really look forward to that. Yeah, Zebi, I know. I mean, it was so sad. I mean, well, we can hope for the best, right? All right, cool, folks. Then I don't want to stand between you and your well-deserved evening drinks. Thank you so much for having me. This was really fun to be here. And well, absolutely, I hope we can meet each other next year in person. If you have any other questions in between, definitely just come to Twitter and we can have an exchange there. And well, thank you so much and see you around.